1B test review. So question number 1, what is the smaller solution of this absolute value equation? So remember, if we are solving, remember we put everything that's on the left side of your equation in parentheses. We put everything that's on the right side in parentheses. And then your equal sign becomes a minus. So then that right there is how we type it in on Desmos. And then also remember, anytime they use a variable other than x, you need to use x when you type it in. So let me pull up Desmos. All right, so then remember, to get absolute value, you click on the keyboard. So parentheses minus parentheses, remember that's the first thing you should always type in. And then you fill it in with whatever the equation is. So absolute value of negative 8 plus 4x. And then on the right side, I've got 18. All right, so both of these points would be my solutions because that's where the graph crosses or touches the x-axis. However, this question is just asking us for the smaller solution. So your smaller solution is always going to be the one that's on the left, because remember we're talking about x. Smaller x values are on the left because that's where they're negative. Bigger ones are on the right because that's where they're positive. So answer would be negative 2.5. So remember, for these, if it's a terminating decimal, that is fine for your answer. If your answer was not a terminating decimal, so if it was a repeating decimal, remember you need to type it in here until your fraction bar disappears and then reappears. So I'll just demonstrate. So let me change this to a 3 so I can make it a repeating decimal. So I've got negative 3.3 repeating. So I would type it here, negative 3.3, and then you spam the 3 till it disappears, then reappears. Click it. So you would put your answer as negative 10/3. So again, repeating decimals, you never ever put the decimal unless the question specifically tells you to round your answer. If it does not say anything about rounding and you get a repeating decimal, that means you need to put your answer as a fraction. But for our question, it was a terminating decimal, so it is totally fine to leave it as a decimal. So negative 2.5. If you wanted to put it as a fraction, then again, same thing, just type it in, negative 2.5, click the fraction, so that would be negative 5/2. So either one of those would be acceptable. If they wanted the fraction, then it should say fraction, like put your answer as a fraction. If it doesn't, then putting the decimal is fine. All right, question number 2, same type of thing. We are solving, so everything on the left goes in parentheses. Everything on the right goes in parentheses. Equal sign becomes a minus. They use D, so again, we need to use X. All right, so I'm going to type that in again on Desmos. All right, so I've got negative 3, absolute value, x plus 4, and then minus 2. And then on the right side, I've got negative 1. So negative 1 on the right. So for this one, does this graph cross or touch the x-axis? No, it does not. So remember, it has to cross or touch the x-axis in order to have a solution. This one does not, so this one would be no solution. So no solution for this one. So it's no solution because it does not touch the x-axis. There we go. Now you can see the whole thing. All right, and then same thing on number 3. So we are solving this. They use A, so we need to use X. So again, everything on the left goes in parentheses. Everything on the right goes in parentheses. Equal sign becomes a minus. So I'm going to type that in. So -2, absolute value of x minus 3 plus 12. And then on the right side, I've got -4. All right, so this one touches at 2 spots. I've got 2 solutions, and they are -5 and 11. So -5 and 11. All right, so anytime you're solving an equation, that's how I expect you to do it. So left side minus right side in Desmos, where it touches the x-axis is our answer. All right, the next few questions are inequalities. So for your inequalities, you do not put parentheses. You just type it in exactly the way it looks. Again, if they use something other than x, make sure that you use x. So 2 times the absolute value of x minus 2 is less than or equal to -10. All right, so for these, if you don't see anything initially when you type it in, zoom out a couple of times. If you still don't see anything, then that means your answer is going to be no solution. So for your inequalities, your solutions are going to pop up as shaded regions. If you do not have anything shaded on your screen, then that's going to mean that your answer would be no solution. So this one is going to be no solution because nothing was shaded. So anytime nothing is shaded, that is no solution. If your whole screen was shaded, then that would be all real numbers. So if I switch this right quick, so if I change this from less than or equal to greater than or equal to, so now if I zoom out a couple of times, so my whole screen is still shaded, so this would be all real numbers. So no shading is no solution. Whole screen shaded is all real numbers. So those would be your special cases pretty much for those. For number 5, so I'm going to set it back to the regular screen. So for number 5, this is the problem. So I'm going to type that in, and then we're going to look at the shading. All right, so absolute value 8 minus 9x is greater than or equal to 19. So notice on this one, I've got 2 shaded regions. So I've got this one on the left, I've got that one on the right. So 2 things are shaded, so that means I need to have 2 intervals written. So this is an interval, that's an interval, so that's 2 intervals. Same thing on this one, I've got 2 intervals. No solution would mean nothing was shaded. We clearly had 2 pieces shaded, so that's not no solution. This means that this would just be one interval. It would start at -11/9 and go to 3. Again, that was not the case. We saw 2 separate shadings, so I should have 2 intervals. That is just one interval, so that's not my answer. So now if you look at these two, the numbers are exactly the same. The only difference is I've got parentheses on this one and I've got brackets on this one. So make sure you know if your endpoints are supposed to be included, which would mean you use brackets, or they are excluded, which means you would use parentheses. So if we go back to our graph, these are solid lines, so that means that our values are included. So remember, solid lines would be solid dots, which means they're included. So included is brackets. So solid lines equal brackets. If they were dotted lines, so say this was not equal to and it was just strictly greater than, then that would change these to dotted lines. Dotted lines are open dots are parentheses. But because these were solid, brackets. So number 5 would be B. Number 6, so they use B for the variable, so we need to use X. So I'm going to type this in, and then I'm going to pick the answer choice that matches what is shaded on the graph. All right, so let me type that in. 4 times the absolute value of 2x minus 13 is less than 11. So this is one region. It goes from a number to a number. These are dotted lines, so that means I should have open dots. So let's look at our answer choices. So this is 2 things shaded and open dots. So I'm supposed to have open dots, but I only have 1 thing shaded, not 2. So my answer is not A. B is looking pretty good. I've got open dots. It goes number to number. I just need to zoom in and make sure those are the right numbers. Down here, I've got solid dots. It's not allowed to equal, and I saw dotted lines. These are solid dots, so that would mean solid lines. I did not have solid lines. So answer has to be B, but let's just double check that these numbers are the right numbers. So it should be -3 and +3. So let me zoom in right quick. So -1, 2, 3 and +1, 2, 3. So yep, that one is my answer. So number 6 is B. Number 7, so the equation 2.1 equals the absolute value of x minus 34 represents the length in inches that is acceptable for a particular brand of baseball bats. What is the longest length in inches that is acceptable? So remember, if we're talking about word problems, x minus 34, so remember it's always x minus the goal. So remember that means the goal is 34. So I'm going to put that in the middle. So that's what it's supposed to be. This number on the end is your margin of error. So that's how much above and below the goal it's allowed to be. So we want the longest length. So that means we want above the goal. So to get our value that is above the goal, we take the goal and we add the margin of error. So I'm going to add 2.1. So 34 plus 2.1 is 36.1. So 36.1 would be your longest. So that is one way to do this problem. You could also see this is an equation. So just like we did up here, to solve an equation, left side minus right side. So you can also do this the same way. So I'm going to put parentheses minus parentheses. So I'm going to type that in, and then I want the longest, which would mean I want the larger or the bigger solution. So this time, instead of the solution on the left, I want the solution on the right. So left side minus right side, I'm going to plug it in, so 2.1, and then this one was the absolute value of x minus 34. All right, so I need to zoom out so I can see. All right, there it is. I want the longer side, so I want the larger solution. So there it is, 36.1. So 2 ways to do the same problem. So whatever your preference is on that. Number 8, what 2 lines make up the absolute value function? So this is my absolute value function. So I'm going to type that in. So y equals 3 times the absolute value of x plus 2 plus 7. Let me zoom back out. Okay, there we go. So that's my absolute value function. So basically, I'm going to type in my answer choices until this line directly matches on top of this absolute value function, because I want the line for the right-hand side and I want the line for the left-hand side. So I'm going to type in my first answer choice. So y equals -3x minus 9. So we get this line. This line is not on top of this part of our graph, so that means that is not our solution. So answer is not A. For B, x minus 1. Not even close. It doesn't even have the same slope. At least the other one had the correct slope, just wrong y-intercept. So not even close, so that's not our answer. C. So I've got y equals 3x plus 4. So again, the slope is correct, but that's the wrong y-intercept because this needs to be up here. So last answer choice, 3x plus 13. So now that is directly on top. And then for the other side, I've got y equals negative 3x, because remember it's going to have plus and minus the same slope, and then plus 1. So now that's directly on top of the other side of my absolute value graph. So that means these two would be the lines that make up this graph. So answer would be D for this one. All right. Number 9. Every family size bag of Skittles should have a net weight of 27.5 ounces. Any bag that is more than 1.1 ounces from the target weight is not sent to the store to be sold, which inequality represents the range of usable weights W. So remember again, it's absolute value of x minus the goal. So remember the goal is what it is supposed to be. So it is supposed to be 27.5 ounces. So that means that needs to be right here. So not those. So these two have the 27.5. Remember, it's x minus the goal. So the only one that has the minus is D, because this one has a plus. So x minus the goal is less than or equal to your margin of error. So margin of error is 1.1, so 1.1 should be on the end. So the answer is D for that one. All right, so that is everything for absolute value that's going to be on the test. So next little section is review questions. So I've got f of x equals this absolute value function. So you can type this in on Desmos and look at it to answer the questions. Or if you remember the rules, you can just answer the questions from the equation without graphing it. So I did it from the equation without graphing it in class today. So I'm going to do it looking at the graph on Desmos this time for the video. All right, so let me type that in right quick. So f of x equals 3 times the absolute value of x plus 1 minus 6. Okay, so this is our graph. So first little thingy thing says, what is the vertex? So your vertex is -1, -6. So -1, -6. So remember, you can also get that switch, keep, or you could just graph it. All right, the domain. So remember, domain are your x values. So does this graph go left and right forever? Yes, it does. So this side is going left forever, that side's going right forever. So it does go left and right forever. So remember, if that is the case, then your answer for the domain is -infinity to +infinity. Your range, those are your y values. So remember, it's your bottom y value to your top y value. So bottom of the graph is at -6. The graph goes up from there, so that's going to be -6 to infinity, inclusive. So this is a solid dot, so I need to put a bracket on the -6. All right, so that right there is my range. It has a vertical shift of. So remember, in general, when we are talking about absolute value transformations, we are comparing our function to the parent function. So I just typed in the parent function. So this black graph is the parent function. So normally the vertex is at 0, 0. Now the vertex is at -1, -6. So the vertical shift, normally it's here, now it's down here. So that's a vertical shift of down 6. Horizontal shifts, remember horizontal means left or right. So again, normally it's here, now it's over here. So I had to go down 6 units and I got to go left 1 unit to get to this point. So my horizontal shift is going to be left 1. All right, and then if you notice, this purple graph is skinnier than the black graph. So remember, when your graph gets skinnier, that is a vertical stretch. So remember, for your parent function, we go up 1 over 1 to get to the next point. For this one, I go up 1, 2, 3, and over 1. So I'm going up 3 times as much as I normally do. So normally I go up 1 over 1. I went up 3 over 1. So I'm going up more than I normally do. So remember, that is a vertical stretch. So that last little bit for that fill in the blank is and is vertically stretched by a factor of 3. So that comes from the front number right here. So front number is bigger than 1, so that's your vertical stretch. Plus 1 inside, that's the left one. So remember, it's grouped with x, so it's the opposite. Down 6 is the minus 6 on the end. All right, so again, review for your transformations. You will have a question like that on the test. Here, more stuff with your transformation. So same thing. This is what we're transforming. So we're writing the new equation that has these components. So it needs to go right 7. So over here, we saw that plus 1 went left. I need to go right, so that's going to be x minus 7. Down 4 units, so that's going to be minus 4. And then reflected over the x-axis, so that is your front number, that's your a value. So that just means it's going to change signs. So normally it's positive, so if I want to reflect it, that means I got to change the sign, so now it's going to be negative. So this right here would be your final answer for that. Number 12, what is or are the solutions to the given system? So remember, your solution to your system are the x values where your two functions intersect. So they intersect right there, and they intersect right there. So your solutions are going to be those x values. So that x value is -1. That x value is +3. So your solutions would be -1 and +3. 13. The graph of the equation y equals k plus the absolute value of x is shown to the right, aka below. If the k in the equation is replaced with a -4, in which direction and how far would the graph shift? So remember, this k, because it's separate from your absolute value, this is the y of your vertex. So currently, because it says this graph represents this equation, so currently your k value is right here, which is at 3. So currently your k value is 3. So now we're saying we're going to completely change that to a -4. So instead of the vertex being at 3, that's going to move your vertex to -4, which is down here. So we started here, we're ending up there. So which direction and how far would the graph shift? So if we're starting here and ending there, that shifts the graph down. So down how many? 1, 2, 3, 4, 5, 6, 7. So that's going to be down 7 units. So that right there, final answer. 14. So anytime you're comparing two functions, in my opinion, I think it's easier to compare the functions in the graphing calculator. So let me grab my graphing calculator. All right, so you want to go to y equals, so top left button. Obviously, if anything's in there, we need to clear that out, so I'm going to clear these out. All right, so in y1, I'm going to put what f of x is. So 2.3x plus 85. And then in y2, I'm going to put g. So 18 times 1.15 to the x. All right, so I put f in y1, I put g in y2. So that's y1, that's y2. All right, second graph to go to the table. So blue button and then graph because I want to go to the table. All right, so here's the table. So what am I comparing? So it says what is the smallest positive integer in which the value of g of x exceeds f of x. So g is in y2, so I need the y2 column to exceed or be bigger than f of x, which is in y1. So I need y2 to be bigger than y1. All right, and then I want the smallest positive integer where that happens. So obviously I'm going to start with the smallest number because I want the smallest positive integer. So I'm going to start with the smallest and work my way up till I find my answer. So I'm already on the table, so I need to scroll down to 12. All right, so here's 12. So is y2 bigger than y1? No, it is not. All right, so 12 is not my answer. All right, next biggest would be 13. So looking at 13, is y2 bigger than y1? So I've got 110, 114. So again, that's a no. 14, is y2 bigger than y1? So that's 127, that's 117. So that's a yes. So 127 is bigger than 117. So 14 would be the smallest positive integer where where g of x is bigger than f of x. So that was where y2 was bigger than y1 in our case because we typed it in here. So 14 is B. 15, so now we're on to piecewise. So end of the review little section, now we're on to piecewise. So remember piecewise functions, those are separate or different functions that we put together and define for specific x values to make one big function. So we use the top part if our x value is less than -3, so if our values are to the left of -3. We use the second part if our x value is equal to -3 but less than +1. So it's allowed to equal -3 up to +1, but +1 is not included. And then we use the last piece if our x value is bigger than 1. So again, 1 is not included. So if it helps you, you could also draw what that means on your number line. So I'm going to do that right quick. So x is less than -3. So I'm going to put -3 right there. It's not allowed to equal, so that would be an open dot. And I would shade to the left because that's pointing left, so I want everything smaller. All right, the middle one. So -3, that one would be a solid dot because it is allowed to equal. Up to +1, open dot, and then anything in the middle. And then the last one, x is greater than 1. So 1, open dot, and then everything to the right. All right, so that's what these intervals mean. So I drew pictures for you. So then which value is not in the domain? So which one of these values does not fit or is not on these number lines? So -4 is -4 to the left of -3 on the number line. Yes, it is. So it would fit in this interval right here, which means I have somewhere to plug it in. So it would not be A because I have somewhere to plug it in. -3. So it can't equal -3 here because that's an open dot. It can here though because that's a solid dot. So again, I have somewhere to plug in -3, which means I can get a value, which means it is in the domain. 1. So 1 is not less than -3, so it's not located over here on the number line. Here, my endpoint is 1, but that is an open dot, so that means it's not included. And then here, right here, for the bottom, again, 1 is my endpoint, it's my starting point. Again, that's an open dot, so that means that 1 is not included. So that means everything after 1, but not including 1. So because both of these are open dots, that means 1 is not in either one of these intervals, and it's not in here because it's not to the left of -3. So there is nowhere that +1 fits into any of these. So that means 1 would not be in the domain because it doesn't fit in any of these intervals. So there's nowhere to plug in the value 1. So this is the one that is not in the domain. Because if you check 5, 5 is to the right of 1. So it fits somewhere. So I have somewhere to put it, which would be the bottom. 1 doesn't fit anywhere, so that one's not in the domain. So which value is not in the domain? Which one of these values is not in the intervals? So which value isn't in the intervals? That would be 1. All right, next page. All right, so number 16. So number 16, so it says use f of x and g of x below to evaluate the following. So let me zoom out so we can see the whole thing. All right, there we go. So if you were using piecewise for multiple problems, I would highly suggest typing it in on Desmos and then letting Desmos evaluate. So remember, when you type in piecewise, you type in your function name, so f of x equals, curly brackets, and then from there, it's the domain, so the right side, colon, so a dot over a dot, and then the right side, so the function. So it's right side colon left side, so it's domain colon function. And then once you are done with that line, you put a comma because we are listing them, and then you start it over. So right side colon left side, then you put a comma, right side colon left side, and then you close your curly brackets because you're done with that. And then you'll do the same thing for G. So then once you have both of those typed in, you can literally just type all this in the next line after that and have Desmos evaluate all this for you. So I would highly recommend doing that for these with the multi-steps. These you don't necessarily have to because it's just singular. You would just have to look, make sure you're using the right function. So like this one's G, so I would be using this. 4, where does 4 fit? 4 is bigger or equal to 0. So you would plug in 4 right here. So the square root of 4 is 2. So that's how that would work if you were doing it by hand. But I'm about to type it in on Desmos, so give me a sec. All right, so f of x equals curly brackets. All right, right side, so x is less than -3, colon the left side, so x plus 3. Done with that line, so comma, next line, right side, so -3 less than or equal to x less than 1, colon the left side, so -x squared plus 4, comma, last part, x is greater than 1, colon the left side, -2x plus 3. So then I'm closing my curly brackets because I'm done with that. Now I'm going to type in G. So G of x equals, curly brackets, right side, so x is less than -4, colon the left side, so -3, comma, right side, -4 less than or equal to x less than 0, colon the left side, x squared plus 4, comma, last line, x is greater than or equal to 0, colon the square root of x. So then for this, make sure you hit the right arrow so that you can get out from under the radical before you close it. So if you aren't and you're still under there and you try to close it, it's going to give you that error message. So a piecewise expression must have at least one condition. So that's saying something was keyed in improperly, and it's that right there. So you should never have curly brackets under your absolute value. It should be outside, so it should be right there. So make sure you hit the right arrow so you're out from under the radical. All right, so now I've got G typed in, so now I can literally go through rapid fire and type in what I need to evaluate. So first thing is G of 4. So I did that by hand, but I'm just going to type that in just to show you that you're going to get the same thing. So G of 4 is 2. That's what we got from doing it by hand. Next one, G of negative 3. So G of negative 3 is 13. F of negative 4. So now I need to change this to F. So F of negative 4, that's negative 1. F of 0, that is 4. F of 5, that is negative 7. And then your multi-step. Let me scooch this over just a little bit. All right, so I want G of negative 2 minus 3 times F of 2 plus F of negative 1. All right, so I get 14 for that one. And then the last one, F of 5 minus 1/3 G of 5 plus F of 1. So that one is undefined, so I'm going to put undefined for this one. All right, so final answers for number 16. All right, so that is evaluating using Desmos. All right, for 17, we are evaluating using the graph. So you can't necessarily type this in because obviously we're getting the values from the graph. So F of negative 8, so that means your X value is negative 8. So that is right here. So the Y value that goes with that is right here. So that would be 4. F of negative 3. So that is this part of your graph right here. There's literally nothing there for negative 3. So if there is no piece of graph for the number that they want you to evaluate, that means that that value is undefined. So I'm going to abbreviate UND for undefined. All right, this one, F of 3. So X is 3. So 2, 3. So that's here. So I've got an open dot. I've got a solid dot. So remember, open dot means that the value is not included there. So technically there is no value here. Solid dot is what you go with. So the solid dot is on 10. So answer is going to be 10. All right, so those are the singular ones where you're just reading the graph. All right, and then we've got this one right here, which is a multi-step one. So I've got 3 different things I need to evaluate, and then I'm going to simplify that number sentence when I'm done, or that expression when I'm done. So F of negative 1, so I need to figure out what that is. So F of negative 1. So that is that point right there. So that Y value is negative 3. So negative 3 goes right there. Minus F of 6. So I need to figure out what that is. So F of 6. So here's 6. So that is this value. So that is 7. And then plus 3 times F of 2. All right, so now I need to find F of 2. So 2 is right here. So Y value that goes with that would be 0. All right, so now this is what I'm simplifying. So negative 3 minus 7 plus 3 times 0. So 3 times 0 is 0. So this last part I'm not adding anything, so I'm not going to worry about that. Negative 3 minus 7. So I'm starting with negative 3, and then I'm getting more negative because I'm subtracting. So that's going to be negative 10. And then if you don't trust me, I'm typing it in the calculator. So negative 3 minus 7. Oop, y'all can't see there's a glare. All right, there you go. So that is negative 10. So final answer for that one would be negative 10. So for the multi-step ones, if you're having to do it from the graph, please, please, please take your time and do it one piece at a time. Take it one piece at a time. All right, number 18. So again, this is a multi-step one. We've got this right here. So I would highly recommend typing it in like we did on this one. So I'm going to type this one in. Function is now h of x. So I'm going to type that in. So function name on this one is h. So let me type that in. So h of x equals, and then just like I did before, right side colon left side. So x is less than negative 3 is going to go first. So don't forget your curly brackets. So x is less than negative 3 colon the left side, x squared minus 2x, comma, next line, negative 3 less than or equal to x less than 1, colon, 3 times 1/2 to the x power, and then right arrow to get out of that, comma, last line, x is greater than or equal to 1, colon, and then for this one, since this is a fraction, I went on ahead and hit the slash on my keyboard. You also could click this to go ahead and pop up the fraction bar. X minus 3 goes on top. 2x plus 1 goes on the bottom. And then close your curly brackets. All right, so then what am I evaluating? Ooh, excuse me. This right here. So h of negative 5. So h of negative 5 plus 2 times h of 0 minus 3 times h of 4. So notice on this, I get 40.6 repeating. So answer choices, I've got 40, 40.7, 41, and 122 over 3. What did I tell y'all about repeating decimals? I said do not round them unless it specifically says to round them. Does this say to round them? No, it does not. It literally says what is the exact value. So since this is a repeating decimal, you are going to need to change it to a fraction, and looky here, what do you notice? The fraction. So I'm going to click that, and what's my answer? 122 over 3. So answer is D. All right, last piecewise problem. So number 19. So it says a remote control plane's altitude, so height in feet, after taking off from the ground can be modeled by the piecewise function f of x below, where x is the number of seconds since takeoff. So then the question that it's asking, after how many seconds does the plane reach its max height? So after how many seconds does the plane reach its max height? So again, type this in on Desmo so you can actually look at the graph. So if you notice, every time I've typed in the piecewise functions, it graphs it for me. Let me zoom out. So there it is. It graphs it for you so you can look at it. So I'm going to do the same thing. I'm going to type it in. So f of x equals curly brackets. Let me pull it back up so y'all can see it as I'm typing in. So right side, 0 less than x less than 4, colon, the left side, 2 to the x, comma, next line, right side, 4 is less than or equal to x less than 8, colon, the left side, 2x plus 8, comma, last line, x is greater than or equal to 8, colon, negative x plus 32. Close your curly brackets. All right, so there's my function. So let me zoom out so we can see it. Okay, boom, there it is. So I wanted the maximum height. Clearly this point right here is the maximum height. And x was the time. So it says x was the number of seconds since takeoff. So the question was, after how many seconds does the plane reach its max height? So that would be 8 seconds. If it asked you what is the max height, then that would be the y value, which is 24. But this one is asking about time, so the answer is x, so 8 seconds. So 8 seconds for that. All right, now we're on to the last section, which is inverses. So for number 20, what is the inverse of f of x equals x squared plus 3? All right, so for this one, remember this is a quadratic. Inverse of a quadratic is a square root, so notice all of these are square roots. Because I would have to solve this, and I would have to square root this myself to get x by itself, anytime you have to square root, you always have to put the plus or minus. So it would not be this or this because they are missing the plus or minus. So you're missing the positive and the negative radical. So answer has to be either this one or this one. So then if you understand how inverses work, remember you are undoing the order of operations because you would have to solve for this variable right here. So remember we switch x and y, so this would actually be y squared plus 3. So I'd have to undo the operations to solve for y. That's a plus 3. So remember you undo that with subtraction. So you need the one that says x minus 3. Only one of them says that. This one says plus 3, so that wouldn't be the same because those are the same operation. So it needs to be the opposite, so it would be C. If you don't remember that though, and you remember that you're supposed to switch your x and y values, remember you can graph this and see which one has the switched ordered pair. So I'm about to do that right quick. So f of x equals x squared plus 3. All right, let me zoom back in right quick. There we go. All right, and then there is no plus or minus button, so you would have to type these in separately. So the square root of x minus 3, and then I need the negative square root of x minus 3. All right, so there we go. So I'm going to pick a point. So that's 0, 3. So for my inverse, I should have the point 3, 0, which I do. So remember, ordered pairs are switched for your inverse. So 0, 3, 3, 0. Remember, they also have y equals x symmetry. So again, that just means your ordered pairs are switched. All right, so answer is C for number 20. All right, 21. So what is the inverse? So this is a linear function. Linear functions are the only one where your inverse is still a linear function. So the function type does not change for the inverse like it does for all the rest of your function types. So same thing on this one. I'm going to solve this one algebraically just to show y'all, and then I'll still go back and show you ordered pairs are switched. So remember, if we're going to solve this algebraically to find the inverse, remember we changed function notation to y. So I'm going to do that in the white space up here. So y equals 3x minus 2. So that's your first step, change function notation to y. Second step is switch x and y. So x equals 3y minus 2. And then last step, solve for y. So I need to undo this order of operations so I can get what y is. So I'm going to undo this minus 2 with addition. So I'm going to add 2. So x plus 2 equals 3y. Last thing, I need to get rid of this 3. So that's 3 times y. So I undo multiplication with division. So I end up with x plus 2 over 3. So answer is D, x plus 2 over 3. So that is how you find the inverse algebraically. So change function notation to y, switch x and y, and then solve for y. All right, so now I'm going to show you the making sure that your ordered pairs are switched. All right, so f of x equals 3x minus 2. f of x equals 3x minus 2. All right, so there's our original function. So now I'm just going to type in my answer choices. So first answer choice is A, so that's x plus 3 over 2. All right. Oh, and let me go ahead and type in y equals x, the reflection line. So remember, I told y'all if we're talking about linear functions, they should intersect on the reflection line. These two do not intersect on the reflection line. They intersect right here. They would need to intersect on this black line, and they do not. Also, this ordered pair for this is 0, 1.5, which means I would need 1.50. I've got 0.6 repeating 0. So again, these ordered pairs are not switched, so A would not be your answer. Similar things with B and C. So let me go ahead and type in B. So B is 2x plus 3. So same thing. That's 0, 3. So I would need the ordered pair 3, 0. Don't have that. Also, these do not intersect on our reflection line, so these are not inverses. Answer choice C, 2x minus 3. Same thing. 0.6 repeating 0, which means I would need 0, 0.6 repeating. I've got 0, negative 3. So again, ordered pairs are not switched. These two intersect right here, which is not on this, so they are not inverses. All right, let me type in the one that was actually the answer. So x plus 2 over 3. So they intersect on our reflection line. I've got 0, 0.6 repeating, which means I should have 0.6 repeating 0, and I do. So ordered pairs are switched, so these two are inverses. So that just reiterates that our answer is D for this one. All right, last few problems. So question number 22. Which of the following is or are true of a function and its inverse? So this is straight from your notes. Ordered pairs are switched. This if is supposed to be with this. So I'm just going to mark this one out. So if f of 3 equals 5, then f inverse of 5 equals 3. So this is just function notation for this. So this is saying your original ordered pair is 3, 5. Your inverse ordered pair is 5, 3. So again, that's reiterating ordered pairs are switched. So the order is switched. So 3, 5, 5, 3. So that's a yes. The graphs of y equals symmetry, yes. If f of negative 4 equals 5, then f inverse of 4 equals negative 5. So this is not switching the order around. This is just switching your signs. When we say the ordered pairs are switched, we mean the actual order, not the signs. So this one's a no. And then this one, if a function passes the horizontal line test, its inverse will pass the vertical line test. So that is the whole point of the horizontal line test. So it's to determine if the inverse is a function. So remember, to determine if something's a function, you use the vertical line test. So if it does pass, that means that every single x has only one y. So that would be your answer. So if a function passes the horizontal line test, that means the inverse will pass the vertical, because that means the inverse is a function. So this one is your answer. This one is not. So these are your answers. So again, that is straight from your notes. All right, 23. Which function has an inverse that is also a function? So this one is asking you which one passes the horizontal line test. So this is absolute value. So remember, absolute value is V-shaped. So does this pass the horizontal line test? No, it does not, because this horizontal line touches at 2 spots. So remember, to pass either one of those tests, it has to only touch once. That touches twice, so that's a no. B, that's a cubic function. So remember, that's the snake in the tree. So that looks like that. Does that pass the horizontal line test? No, it does not, because again, it touches multiple times. So it can only touch once, so that is a no. That is a linear function, so that is a straight line. Is that going to pass the horizontal line test? Yes, it does. Why does that look fuzzy to me? I don't know, maybe I'm going crazy. Oh, nope, that looks clear. Okay, it wasn't just me. All right, so it only touches once. Remember, in order to pass, it has to only touch once. That only touches once. So answer is C. And then if you wanted to check, D is a quadratic. Remember, quadratics are U-shaped. So again, that is definitely not going to pass. It's going to touch more than once. So if you don't remember your shapes of your graphs, then you also could have just typed these in and looked at the graph and seen that these shapes are these shapes, and still done your horizontal line test. You would have seen same thing. I just went on ahead and just drew the pictures. But you could also type these in so you can get what they look like, and then hold your pen or pencil up horizontally and see how many times it touches. So answer is C for this one. So remember, in your notes, I wrote linear in all caps. It's always the linear choice. All right, 24. Determine if each function is one-to-one, not a function, or a function but not one-to-one. So remember, to be one-to-one, that means that no x's and no y's repeat. So that means it has to pass the vertical line test and the horizontal line test. So this one, it passes both. All right, if it's not a function, that means it doesn't pass the vertical. And then if it's a function but not one-to-one, that means it only passes the vertical. So only passes the vertical. So VLT. All right, so negative 5x plus 1. So for these, I'm just going to graph these because some of, or at least this one right here we haven't talked about. This is the equation of a circle. So I'm going to graph these on Desmos so I can show you what the graphs are going to look like. So negative 5x plus 1. Negative 5x plus 1. All right, that is a straight line. That is going to pass both. So it passes the horizontal line test. It passes the vertical line test. So it passes both. So that is a one-to-one function. So that would be A. This one, that's absolute value. So absolute value, x minus 2. All right, this one passes the vertical. So it is a function. It does not pass the horizontal. So that means it's a function, but it is not one-to-one. So it only passes the vertical. So that is C for that one. This one, so this is the equation of a circle. So we haven't gotten the circles yet because we're still in unit 1. So x squared plus y squared equals 0. All right, let me zoom in. Oh, not 0. I don't know why I put 0. It needs to equal 1. I'm slow. All right, so equals 1. So again, let me zoom in. All right, so there's your circle. So does it pass the vertical? No, it does not. It touches twice. Does it pass the horizontal? No, it does not. It touches twice. So it doesn't pass the vertical, so that is not a function. All right, for this one, 2x to the third minus 5x. So let me type that in. 2x to the third minus 5x. All right, so this is going to pass the vertical, but it is not going to pass the horizontal. So that's going to be a function, but not one-to-one. So that is C. And then last one, square root function. So square root of x. So it passes the vertical, and it also passes the horizontal. So that one would be both. So that is A. All right. Last 3 questions. All right, 25. So if the inverse of 9 equals 2, which equation is the original function? So this is saying I've got the ordered pair 9, 2. So inverse ordered pair is 9, 2. That means my original ordered pair is 2, 9. Because remember, ordered pairs switch. All right, so I'm going to type in these. Again, if I'm looking for ordered pairs, it's best to type it in on the calculator. So I'm going to go to y equals. I'm going to type all 4 of these in so I can check the tables for all of these. So 2x squared minus x minus 25, 4x minus 3, x to the third. Let me get down from there. All right, so x to the third minus 4x squared plus x. And then last one, 2 to the x plus 5. So second graph. All right, so I'm looking for the ordered pair, 2, 9. So which one of these has the ordered pair, 2, 9? So 2, 9. So there it is. So that's the one that's in Y4. So the one that's in Y4 is the last one. So D would be my answer. All right, 26. So find the inverse of 2. So if you notice, this table is your original function. We want the inverse of 2. So if we're talking about the inverse, your x value, let me go back to this one for a second, your x value for the inverse is your y value for the original. So because I want the inverse of 2, that means this 2 is my y for the original. So that's what I'm looking for. So I'm looking for 2 in the y. So 2 in the y is right here. So the inverse of 2 is going to be 0. All right, last question. So which pair of functions shown in the graph below are inverses? So I've got linear functions. So remember, I'm going to draw in my reflection line. So y equals x. So I'm just going to draw it as a dotted line. All right, and then because these are linear functions, if they intersect on the reflection line, that means that they are going to be inverses. So line J intersects line F on the reflection line. So that means J and F are inverses. So J and F. And then I've also got these two right here. So that is H and G. So those two are also inverses. So H and G. So J and F, H and G. So H and G, J and F. So F and J. All right, so that right there, final answer. All right, so that is your test review. If you have any questions, please feel free to email me with any questions that you have. So your test is tomorrow, so happy studying and good luck.